Welcome to the Explainer. Today, we're going to pull back the curtain on computer networking. Forget all the super dense technical jargon. We're going to give you the essential blueprint, the real-world guide to how our digital world actually connects.
I mean, seriously, have you ever felt like you need a PhD in engineering just to figure out why your Wi-Fi is slow? It can seem incredibly complex, right? But what if I told you that the core ideas behind it all are actually surprisingly logical and easy to grasp?
You know, the best way to really understand something is to build it. So that's exactly what we're going to do. We're going to become network architects, and piece by piece, we're going to design a working network from scratch. Okay, let's dive in. Every great project, whether it's a skyscraper or a website, starts with a blueprint. Our network is no different. We've got to decide on its fundamental structure. So our first big question is this: how are all the computers going to share information? We've basically got two main models. For a business, you'll probably want a dedicated server. Think of it like a central library, one place to get all the books. But if this is just for your home, a peer-to-peer setup is perfect. That's more like a casual book club where everyone just lends out their own books to each other. All right, next up, the actual physical layout, or what the pros call topology. Now, way back when, you had the bus design, basically one long cable. The problem? If that one cable broke, the whole network went down. Ouch. On the other extreme, you have a mesh network, which is super reliable but complex. But really, one design rose above them all to become the modern standard we use almost everywhere today. And that winner is the star topology. It's brilliant in its simplicity. Every single device connects directly to a central point. So what happens if one computer's cable gets accidentally unplugged? Nothing. Everybody else stays online, completely unaffected. That's why it's the standard. It's just so resilient. Okay, our blueprint is ready. We've decided on a peer-to-peer network using that star layout. Now it's time to get our hands on the actual hardware, the physical gadgets that are going to bring this thing to life. Let's start with a little piece of history, the hub. I want you to picture a town crier. When a hub gets a piece of information, it just stands in the middle of the town square and shouts it out to everyone. As you can probably guess, this creates a ton of noise and causes a lot of traffic jams, or what we call data collisions. Now, the modern and much smarter replacement for the hub is the switch. This thing isn't a town crier. It's more like a super efficient postal worker. It's intelligent. It actually learns the unique address of every single device plugged into it. So how does it do that? How is it so efficient? Well, when a little packet of data arrives, the switch doesn't shout. It just quietly reads the destination address, checks its internal address book, and then creates a direct private connection only to the computer that's supposed to get it. It's that simple step that makes modern networks so fast and efficient. Okay, so a switch is fantastic for connecting all the devices inside our own network. But how do we connect our network to, well, the rest of the world? That's the job for our navigator, the router. Its whole purpose in life is to connect different networks together, most importantly, connecting our little home network to the giant global internet. We've got our layout, the hardware is all plugged in, but right now it's just a bunch of plastic and wires. For these devices to actually talk to each other, they need a common language. They need an address system. They need the rules of the road. Now, you might hear networking experts talk about the 7-layer OSI model. It's a great theoretical concept for learning. But here's what you really need to know. The entire world, the whole internet, actually runs on the much simpler 4-layer TCP/IP model. That's the one that really matters. And this right here is the perfect way to think about how network addresses work. It's a two-part system. The IP address, that's like the street address of a building. It gets the data to the right computer. But once it arrives, the port number acts like the apartment number. It makes sure that data goes to the right application, whether that's your web browser, your video game, or your email. So where do all these IP addresses come from? Do we have to type them all in by hand every time we connect? Thankfully, no. Instead, our devices just ask a handy little service called DHCP. It's like the network's automatic address manager, handing out a unique IP to any device that joins. And this all happens in a lightning-fast 4-step conversation that people in the industry call DORA. Your device wakes up and shouts out a discover message, "Hey, is there an IP address for me?" The DHCP server hears this and makes an offer. "Yep, you can have this one." Your device sends back a request. "Awesome, I'll take it." And finally, the server sends an acknowledgement. "Great, it's all yours." And this happens in milliseconds.
But let's be real, none of us walk around remembering long strings of numbers. We use names, right? Like Google.com. Well, the magic that makes that possible is called DNS, the Domain Name System. And it's basically the entire internet's phone book, instantly translating the names we type into the IP addresses computers actually need.
And there we have it. Our network is officially live. The hardware is talking, devices are getting addresses, and they can find each other. But, building it is really only half the battle. Now we have to manage it, and maybe most importantly, keep it secure and healthy. When it comes to network security, you can really boil it all down to two fundamental ideas. On one hand, you have prevention. This is about building strong walls, your firewalls, your antivirus, keeping things updated. But here's the thing, no wall is perfect. So you also need recovery. That's your escape plan. It's having good backups so you can get back online if the worst should ever happen.
And when things do go wrong, and trust me, they will, every network admin has a basic first aid kit of commands they turn to first. If you need to check your own computer's address, you type ipconfig. Want to see if you can even reach another computer? You ping it. And if you think the internet's phone book is failing you, you can test it directly with NSLookup. 3 simple tools that are incredibly powerful.
So look at what we did. By putting these simple building blocks together, we've gone from this mysterious black box to a clear, logical system. You can actually see the structure behind the invisible connections we rely on every single day. And having that foundational understanding, well, that's pretty empowering in this super connected world we live in.
We've built a network from the blueprint all the way to the rules of the road. So the next time your internet flickers, you'll have a much better idea of that silent conversation happening between all those devices. We've shined a light on a part of the invisible world that powers our lives. So the only question left is, what part will you explore next?